You know, billions and billions of dollars flow through government programs every year. And hidden inside all that data, some really sophisticated fraud is thriving. Today, we're going to go on a little digital investigation to see how modern tools can uncover crimes that are, well, almost impossible to spot with the naked eye.
And that, right there, is the central problem for fraud investigators. They're not looking for some smoking gun. They're hunting for a ghost in the machine. It's a pattern hidden across millions of transactions that on the surface look completely normal.
So where does an investigation even begin? Well, it almost always starts right here, with what's called flat data. Just think of a massive spreadsheet, a really long list of who got paid and how much. It's a starting point, sure, but the real story, the criminal conspiracy, is buried way, way down beneath the surface.
This security camera analogy it perfectly captures the problem. A simple payment list shows you the check going to a contractor, but it tells you nothing about what happens next. Who do they pay? Do their claims even match reality? All the most important clues are happening just out of sight. Right, so to crack this case, investigators have to get inside the building. They've got to start connecting these basic clues to see the bigger picture. And this is where the first major breakthrough happens. With the simple list, you're just stuck. It's a total dead end. You can't see the chain of payments. You have no way of knowing if a daycare is claiming it has 50 kids when it really only has 10 enrolled. You can't spot 5 different companies that all happen to list the same address. You're completely blind to any organized networks. But what happens when you start connecting the data? All of a sudden, you can ask these incredibly powerful questions. An investigator can instantly check, wait, is the same child being claimed by 3 different daycares at the same time? Do these 2 companies that look separate actually share the same bank account? This is how you catch that first level of fraud, the duplicate claims and the ghost children. And the tool that makes all of this possible, it's called a relational database. It basically transforms that simple flat list, that checkbook, into a full interconnected accounting system. It links providers to claims, claims to payments, and providers to owners. It's these connections that start to tell the real story.
Okay, so connecting the dots catches these simple schemes. But what about the masterminds? The people who aren't just filing a few false claims, but are running an entire criminal enterprise. For that, we need to go even deeper.
See, these operators are smart. They know investigators are looking for things like duplicate names and addresses. So what do? They build these complex webs of shell companies, using different names, different LLCs, all to hide the fact that one person or one group is pulling all the strings. Their goal is to look like a dozen small, unrelated businesses, not one giant fraud ring.
So, if you want to untangle a network, you need a tool that actually thinks like a network. This is where graph technology comes in. Instead of seeing data in rows and columns, it sees it as nodes. Things like people, companies, or bank accounts, and edges, which are the relationships between them, like owns, or paid, or shares an address with. And this is where you can really see the power of this thing. Person B doesn't own company X directly. No, they own company Y, which in turn owns 50% of company X. In a spreadsheet, that's a totally hidden link. But in a graph, that connection is immediately visible and it exposes person B as a hidden owner. It just cuts right through all the shell games.
And then, when you apply this thinking to the whole data set, you get this. This is that huge aha moment. What looked like hundreds of separate little dots suddenly connects into this massive organized network. The red nodes you see in the center, those are the masterminds, the key players. You can see exactly how the entire operation is structured.
And this quote just nails the difference. A graph lights up these suspicious clusters like a Christmas tree. But a spreadsheet, with the very same data, just shows you 5 seemingly unrelated rows. You would never, ever know they were all part of the same scheme. Okay, so now we've got the tools. We can see the crime. The final step is putting them all together to build a system that doesn't just solve fraud after it's already happened, but actually shifts the entire approach to preventing it from happening in the first place. So let's break down how this whole system works. An impossible claim, like a daycare billing for 30 hours in a single day, gets automatically flagged by the relational database. A hidden network of shell companies? Well, graph technology instantly spots that suspicious cluster and uncovers who the real owners are. Each risk has a specific tech solution working to stop it. And this is a really crucial point, especially for us taxpayers.
The big multi-million-dollar payments from the federal government to state agencies are generally pretty safe. They're heavily audited. The real vulnerability is downstream, scattered across thousands and thousands of smaller reimbursement claims from individual providers. That's where the money leaks, and that's exactly what these tools are designed to protect.
You know, when you get right down to it, this is the main takeaway. It's not about hiring thousands more auditors to reactively chase down fraud. It's about building smarter systems that can proactively see the patterns that we humans just can't, making sure the money goes where it's supposed to from the very start.
So, we've gone on a journey here. We've gone from a confusing, static list to a clear, living map. A map that shows not just where the money is supposed to go, but where it actually ends up. It gives investigators the vision they need to follow the money, no matter how cleverly the criminals try to hide the trail.
Which kind of leaves us with one final big question. If connecting the data can reveal these massive hidden fraud networks, what other complex, invisible problems could we start to solve just by looking for the hidden relationships between the dots?